Welcome to ECE 3300 at the University of Utah. In lecture number 14, we're going to talk about vectors and coordinate systems. We're going to talk about the definition of a vector, what a unit vector is and how to find it, the direction and distance between 2 points, how to find perpendicular and parallel vectors, and vector math, such as adding, subtracting, dot product, and cross product. We're also going to be talking about the 3 major coordinate systems, Cartesian, cylindrical, and spherical, and how to find integrals in line, surface, and volume. A lot of this material is likely to be review to you, so feel free to skip to the sections of the lecture that are important or that you don't remember as well. This material is also covered in your textbook, so you might want to thumb through the textbook to find the things that you don't remember. Here's an example of a vector. A vector is defined in the x, the y, and the z directions. Here's the orientation of x, y, and z in the Cartesian coordinate system. A vector has an x component, ax, and a y component, ay, and a z component, az. The way you find the vector is you just kind of do a projection of all of these. And the vector goes from the origin to this corner point that has ax, ay, and az. That's the corner point, and here's the vector a. If we wanted to find the magnitude of a, we would take ax squared plus ay squared plus az squared and take its square root. If we wanted to know its direction, we might call that a unit vector, and what that would be is a, the vector a, divided by its magnitude. So that would be in the x direction, ax divided by the magnitude of a, in the y direction, ay divided by the magnitude, and in the z direction it would be az divided by the magnitude. A would just tell the direction of the vector without telling us anything about its magnitude. So if here is a bigger picture of the a vector, then a, the unit vector, would be a vector in the same direction, and the magnitude of a unit vector, any unit vector, is 1. Another way that we can write a is we can say that a is equal to the direction a times the magnitude of that vector. Now let's consider 2 vectors, a and b. Here is a vector a, like this, and here is a vector b, like that. If we wanted to add these 2 vectors and get c, where a plus b is equal to c, then what we would do is add each individual component, like this. And so on. A picture of what this would look like is that we would take vector A and we would take vector B and put it at the end of vector A until it went like this, and there would be vector C. Some important things to remember are that A plus B is equal to B plus A. If instead we wanted to subtract them, we would simply subtract the components instead of adding them.